see you too.
Background, it looks like you're relaxing on the beach.
Yeah, we need to imagine that.
I remember the last time I met you was in Taiwan. Actually, I was on campus at your lab and
Yes.
yeah, a really in-depth presentation. But I just want to introduce you a little bit. You're now leading a large biomedical engineering team doing research in this medical research, what is it called? 3D Printing Medical Research Institute at China Medical University Hospital. Is that correct?
Yes, correct.
I was very impressed at the time that you're leading a really large engineering team. Why don't you share with us what exactly do you guys do?
You know, most of surgeons or physicians, they really don't know what is 3D printing. But our high level, our hospital high level, they believe new technology like artificial intelligence or 3D printing or very, very new technology probably help our hospital can developing a new tech for the patients or to provide a better service. So we set up this lab or this center 5 years ago, and then the hospital really gave me the large resource to hire people to purchase the equipment, the best equipment. And then we start to approach the clinical unmet need. But you know, my background is not from the medical field. So it's quite challenging for me to understand the gap between the two fields. And then I believe we probably done something correctly. So our application and our technology already penetrate into our hospital. And then this bring another impact. So other hospitals in Taiwan, they observe we probably giving a new application or provide a better tools to surgeons. So they start to consult with us. And then it become a wave in Taiwan and to all those hospitals to set up their own 3D printing center in hospital.
That sounds great. That sounds the investment is paying off from the hospital side.
Right.
And you guys are doing a lot of projects. I remember last time, well, actually recently you wrote a couple of expert corner blogs. You know, at first it was talking about pre-surgical planning software,
Right.
the whole workflow process. And then now you're actually also working on bioprinting projects as well.
Right.
So it's not just 3D printing for anatomical models, but really a variety of research and development and applications. So what are you working on right now at the moment?
You are right. In the very beginning, it's very difficult or challenging for us to print an organ, you know. But the main goal for medical field and 3D printing can do is we imagine, can we print out an organ, a tissue, a human part? That would be the end goal. But however, it's not so clinical. It's not so application into the real world. So we start at a very low level, like we can print the anatomic model, as you said. But in the end, we find out why can we doing better things, like we help the surgeon, we help the physician, we change their decision plan, or we change their mindset. So we start to working with some the surgeons. They will provide their unmet need, like they don't know how to planning the precisely, or they don't know how to observe the some issues they cannot understand before they doing the surgery. So we help them, especially in spinal surgery. We help them to provide a software. This software were based on 3D printing technology, and this software can help them to build up the digital model, to doing the planning, and then we can do the like the spine segment. And in the end, we are able to provide the bone density of the spinal. So I believe we really can help the surgeon to do the better surgical planning, and then we provide the precise template or the tools when they are doing the surgery, and then after then we can help them to evaluate the results, to evaluate the outcomes. So that would be the second stage. But the end stage, go back to what I said. How can we print out the tissues, organs? Will be the end goal. So we need to put the resource in. I mean, in the very beginning. Therefore, after 10 years, we can see the progress. So therefore, I purchased a lot of like bioprinter, and we have the engineer who is in in the different fields. Probably they are stem cells expert, or they are biological expert. And then we using bioprinter as a tool to construct the different material. And then we discussion the interaction between the cells and the biomaterials. Then we are trying to build our foundation of the printing organs research. So that's what we do.
Is it hard to transition from, regular polymer metal printing to bioprinting?
Yeah, it's totally different fields.
Well, I can imagine the challenge.
Yeah. But fortunately, we got a lot of research in our university who is understand sales better than the engineer. So what we do is we bring the two groups people together, and probably the biological backgrounds person, they don't know how to use a bioprinter, but our engineer can help that. And then along this research or collaborations process, then both of fields people, they will build up their domain knowledge, I believe.
So it's a learning curve, basically.
Yes, right.
Yeah, and also we haven't talked about the topic of implants. So lately there are a lot of discussion about point of care 3D printing,
right.
where hopefully we can print patient-specific implants locally at the hospital. Is this something that's already taken place at your hospital or something else?
Not really. I believe it's not the technical problem. It's a regulation problem. So our hospital is not allowed to print anything for clinical use. We will need a regulation certification to do that. But the hospital is not allowed to do that. So we spin out a very small company. The small company is processing like the ISO and all the certificate, the regulation issues. And then they will provide the service to the hospital. But the basic design and the planning procedure and the communication with surgeons is the duty of our center.
I see.
Yeah.
So the manufacturing process is outsourced, basically.
Right. I believe it should be the same situation, I mean, in United States, but I'm not sure what's the current state for the Europe right now.
Yeah, I have to say, I've seen cases where, I don't know if, I think in hospital, actually, at least I've seen cases in East Europe, they have done that. I think it is possible for, I think maybe some of the hospitals have done 1 or 2 cases using metal 3D printing for implants for emergency use or just really complex cases. But I have to say, this is a very blurry area. I mean, this is
Right.
one interesting discussion is, can hospitals become manufacturers self, and that would change basically the business strategy for hospitals.
That's right. That's right. Yeah, that's right.
Well, one of my biggest impressions when I was in Taiwan was that I feel Taiwan is an untapped treasure box. There's so many smart people who are extremely well educated, either in medicine or technologies, and there are a lot of inventions or a lot of innovations. Some are state sponsored, some are privately sponsored. But I feel like I don't know how much the world knows about it. So when I was reading your written interview, and you said that Taiwan is really a good location to continue innovation and manufacturing of some of these emerging tools. Do you want to just elaborate on that a little bit more for us?
Yeah. That would be my honor to do that. In Taiwan's education process, the most smart students, they go to the medical school.
I know that.
Yeah. And the second the second level, they are smart as the same the surgeons or physicians. They go to the ICT industry. So in Taiwan, we have a very strong machine tooling industry. We have semiconductor industry. And I believe we are the provider for the whole global world for the both industry. And since healthcare system is very localized, is a very domain dominant direction. So if our engineer from the ICT or from the machine tools industry, they are able to help the healthcare person to build up the innovation tools or medical device, that would be help, and we are able to do that. The question is, how can both fields people they exchange their domain knowledge? It's because we have a so different backgrounds education, so it's quite a challenge. When I first go to the hospital as a director of the 3D printing medical center, and I talk to the surgeons, it's quite impactful for me because we are talking about the difference or the tolerance about the 1 micron, 2 micron, but they are talking about a millimeter. So I believe how to bring two fields people together and work. And since in Taiwan we have both expert or talents to do that, I believe we are able to invent, or we are able to become a island with the new medical device for healthcare, the medical device provider for the healthcare. And we are able to design, we are able to manufacturing, we are able to, we have a very good healthcare system. So with three parts, those three parts, I believe we can become the very good provider for the world, for the healthcare.
Yeah, I'm a little bit jealous of Taiwan's healthcare right now as we're speaking.
Thank you.
Well, thank you very much for this interview with us, Evin. And I very much look forward to your presentation in our upcoming June event, 3D Heals 2020, where you're going to share more of your work and Taiwan with us.
Me too.
Thank you very much.
Thank you.
Take care.